In order to find out the mass of 2 cubic centimeters of gold that has a density of 19.3, it's probably first worth considering that density of any object is going to be equal mass over volume. So using my algebra, if I'm trying to find out the mass, I can rearrange this equation so that density times volume is equal to mass. Now in this case, I'm trying to solve for the mass, so essentially I'm going to multiply the density times the volume. Doing my multiplication, 2 cubic centimeters multiplied by 19.3 grams per cubic centimeter will give me a product of 38.6 grams. But using significant figures, since the measurement 2, or the volume, only has one place of accuracy, my answer probably should only have one place of accuracy, and so my answer is going to be 40 grams. Now the important thing about this is if you're going to do the problem, just this problem by using the equation, you have to be careful about the units. In this case, centimeters and centimeters are going to cancel out, and therefore when you multiply them together, you're going to end up with 40 grams. Doing the same problem with dimensional analysis, it's fairly obvious how the units cancel out. The original volume was 2 cubic centimeters. The density was 19.3 grams, would equal every 1 cubic centimeter. So when you multiply these two terms together, the units of cubic centimeters will cancel out, and my dimensions that I end up with are obviously going to be grams. And that's how I get my answer to be 40 grams. In this case, we're trying to find out the volume in cubic meters that 55 pounds of lead would occupy, and lead has a density of 11.8 grams per cubic centimeter. Now, initially, some people might try to solve this problem by rearranging the density equation so that mass divided by density could equal volume. That's not necessarily a bad idea, but they're going to run into problems when they go to take the mass, which is 55 pounds, and they divide by the density, which is 11.8 grams per cubic centimeter. Hopefully you can see that the units of pounds, 55 pounds divided by 11.8 grams per cubic centimeter, there's a problem dimensionally with the mass units, and furthermore, when you finish the problem, there's still a unit of volume unit problem, because this is in terms of cubic centimeters, and we want the answer to be in terms of cubic meters. I would strongly suggest using dimensional analysis for this problem. So starting off my dimensional analysis scheme, I would initially begin with 55 pounds. That's 55 pounds of lead. I looked in the back of my book, and there are 454 grams in a pound. So multiplying by this first conversion factor, I can change the mass of lead from 55 pounds into its equivalent in terms of grams. Then I can use the density, which is 11.8 grams per cubic centimeter. Notice how I organize the density, though. I said there are 11.8 grams per every cubic centimeter, but I put the 11.8 grams on the bottom so that grams and grams would cancel out, and now I would have the volume in terms of cubic centimeters, which is really close to the answer I want, except I want it in terms of cubic meters. And so I believe there are 100 centimeters in every meter. Now, to make that a cubic conversion, I would cube the entire thing. So I'm going to put parentheses around this, and hopefully I can cube that whole thing. That way, cubic centimeters are going to cancel out, and my answer will be in terms of cubic meters. So using my calculator, I found out that 55 pounds of lead having a density of 11.8 would occupy a volume of 0.00212 cubic meters. Using significant figures or accuracy, I see that 55 only has 2 places of accuracy, so my final answer is going to be 0.0021 cubic meters.